This is the Introduction to LID for Developers and Contractors. So my name is Jason King. I'm a landscape architect with 17 years of experience. My focus has been predominantly stormwater design and working on incorporating site design strategies. A lot of the stuff we're going to talk about today, LID strategies, site design, and then specifically stormwater design. I've done a lot of green roofs, stormwater facilities, permeable paving for really high density to low density residential.
I'm Chris Webb, and when I relocated to Washington State almost 20 years ago, I was fortunate enough to get involved in some of the early low-impact development installations, and that really has been my focus from design right through construction.
We'll do the introduction, talk a little bit about regulations around LID for the state of Washington. And the second part, we'll do an overview of site assessment, planning, and layout, specific BMP strategies for LID, and then talk a little bit about cost comparison and return on investment, and then wrap up. So the first section, introduction and regulations. We're not going to get into super detail on a lot of the design and engineering, so it'll give us an overview. So the idea of looking at LID BMPs, looking at the regulatory requirements for the state of Washington applied by Department of Ecology, looking at LID compared to traditional development and comparing those two, which is a good sort of way to differentiate. And then what we'll talk about is the site assessment, layout, and planning for these projects. And then a couple of things at the end, minimizing construction impacts, minimum requirements for construction. For starting off, we're going to talk about why you would do LID. LID is not just about stormwater management and BMP. It's about a technique for planning and designing sites that minimizes the impact and maximizes opportunities to do on-site management. How we did things 20 years ago is instead of centralized systems where you put like a pond in a particular place, we look at the idea of small scale and distributed systems and the idea of looking at development in certain areas and protecting open space in other areas through a variety of techniques. One of the things obviously that does is reduce impervious area. By decentralizing it, minimizes the concentration of stormwater. And then a key part of this is the fact that we need to really look closely at the site and what the site's telling us in terms of hydrology, soils, adjacent ecology, not just kind of going in and wiping the slate clean and building whatever we want, but really responding to the existing conditions in that way. The function of looking at a pre-developed condition, both as a metric for determining how to manage stormwater, but really what it is a fundamental way of looking at the site and saying, what was here before development and what is the type of development that we want to create and how does that mimic and restore some of that pre-development condition. So what we have is the concept of high amounts of evaporation and evapotranspiration, high amounts of infiltration and recharge of groundwater, and then this sort of balanced cycle that connects those two. When we have development, we turn that into significantly lower amounts of evapotranspiration. We have less vegetation, so we have less evaporation. We have much higher levels of impervious surface. That leads to less infiltration, less groundwater recharge, more runoff, and potentially transportation of pollutants into water bodies. One of the things we'll talk about when we look at the difference between LID and traditional planning is you see these two different site plans. Your left would be the idea of a traditional development that we would probably see more commonly pre-2000, but the idea of an LID development that's going to have a very different look and feel. And one of the things that does is, like I said, going back to minimizing disturbance, really focusing on reducing impervious areas, by looking at what resources we have available, being able to protect and restore the soils and vegetation, and then looking at stormwater management as a decentralized system that can be woven throughout the site. The driving factor in this is looking at opportunities for infiltration, filtration, storage, evaporation, and transpiration. All of these combine to create the stormwater management structure, which, as we all know, is driven by our fun Washington Municipal Stormwater Permit.
I wanted to provide some context for kind of why I think this discussion is happening today, and kind of key for those who aren't familiar with the kind of permitting system that controls stormwater in Western Washington, both in the state So from the Clean Water Act, we have the NPDES system, which is the essential permit process, and those permits are issued to wastewater plants and so forth. But there is also what's known as a general permit, which applies for all stormwater. And municipalities that operate a separate stormwater system have those permits. And that permit process, you can see here the municipalities that have over a certain population have to have one of these permits, and those permits are issued by the state. And it's that permit process that is requiring LID, which then filters down to land use codes and so forth that we end up needing to live with and work with on our project. There are some significant dates which I think are important to know about when these new requirements will take effect. So municipalities by that permit are required to update their codes. There's a whole series of elements in the permit, but the ones that I think are most germane today are updating development codes to require consideration of the feasibility of LID. And the key date there is really December 31st, 2016. And there's a series of dates when certain things in certain jurisdictions, there's a kind of a rolling implementation, but that's the one when most requirements will go into effect in most jurisdictions. Within the permit, there are a whole series of minimum requirements for development, and the ones that you see in bold there are the ones that are really going to focus in any level of detail today. That is the construction stormwater pollution prevention plan, the construction SWIP that we use for our erosion control, the requirements for minimum requirement 5, which is to manage stormwater on site, and that's got a significant implications and value. LID has significant value to meet minimum requirement 5. And then 6 and 7 for treatment and flow control, of course, LID practices address those minimum requirements. So minimum requirement number 2 is our construction SWIP, our erosion control plan, and there's a new element in the current permit called element 13, which is added to our SWIP, which is about the protection of low impact development practices from sedimentation. And so that's a new element that needs to be addressed in the SWIP, and the CESOLs on site will have to be thinking about that. We'll need to be phasing our construction, managing our runoff during construction and so forth to protect the BMPs. Minimum requirement 5 is the requirement to manage stormwater on site to infiltrate, disperse, and retain to the maximum extent feasible. There's a lot of misconceptions about that, I think. Low impact development in the permit is required to be used where feasible. So I think there's been some misconceptions that LID in the permit is required on all sites. However, there are infeasibility criteria for each practice, and we'll go over the process by which we determine that. So it's not a function of we have perched groundwater at 1 foot depth and till soils and we have to do LID. In those cases, certain infeasibility criteria will be triggered and LID is not required, although technically through design I think we can make LID work in many of those situations. Minimum requirements 6 and 7 are really the workhorses for stormwater treatment, for pollution generating hard surfaces, and flow control. We're meeting our hydraulic requirements, meeting our pre-developed forested condition runoff durations. The process by which the LID feasibility process happens, and this was one of the handouts that's available on Ecology's website. Essentially 2 paths to use to figure out what LID is going to be required on my site. We have the List 1 and List 2 process, which is kind of a small version here. Again, it was available as a handout, where when you go through the process to determine which minimum requirements apply to your project, be it by the amount of land clearing you're doing or the amount of new hard surfaces you're building, then if you're only required to implement minimum requirements 1 through 5, then essentially you march through list number 1, or you sort of have the second option, which is an option to simply meet the LID duration standard, which means to basically put a pond in that meets the type of performance that LID provides in terms of the modeled duration curves and from a flow control point of view. But I think that when one were to run those calculations, one is going to find that that results in sort of in a very, very large pond, and probably an unreasonably large pond, and that it's far more advantageous to go through the process of evaluating which BMPs are feasible, use those that are feasible, don't use those that are not feasible, and then move on and model the rest kind of per traditional methods. But this is not a design class, so I don't want to get too into the weeds on that. But to let you know that there is a process by which The practices are determined to be feasible and infeasible. You implement the ones that are feasible, and then you go on from there. So, as we mentioned, these practices are used to help to address minimum requirement 5 to manage stormwater on site, and they may address your treatment and flow control requirements depending. In the manual, in Ecology's manual, there are several LID BMPs that are described. One nuance that I would like to point out is the difference between rain gardens and bioretention. This is a kind of a new distinction between these terms. I think for the past 8-10 years, those two terms have really been used interchangeably. But now it's important to know that a rain garden is different from bioretention, and that a rain garden is defines those things that are very informally built, maybe by a homeowner, usually with maybe amended site soils, not typically designed by an engineer. And then there is bioretention, and bioretention could look very similar to a rain garden. However, they have fully replaced soils and have to meet a higher degree of specifications on their use. One's a more formal and an informal version of very similar topics. Minimum requirements 6 and 7, of course, we've got our treatment and flow control, and each of the LID practices can variously meet our requirements for treatment and flow control. You can see there, for example, a bioretention cell, of course, does treatment and flow control, whereas a green roof is really not a treatment BMP. That's a flow control practice because it's not, cleaning water from a pollution-generating hard surface.